So we've been told that one uranium atom, has a mass of 3.95 times 10 to the minus 22 grams. It's a number, get your pen out and underline it, right? We've then been asked to work out an estimate for the number of uranium atoms in 1 kilogram of uranium. So let's just try and visualize what's going on here. We've been told that one single uranium atom, weighs 3.95 times 10 to the minus 22 grams. All right, then what we're going to do is we're going to try and put lots of these uranium atoms together to essentially form a 1 kilogram block of uranium, right? And what we've been asked is how many, so the number of uranium atoms, how many of these single atoms will make up this 1 kilogram block of uranium. Okay. So if I put lots of these uranium atoms together to make up 1 kilogram, then all I'm doing is saying, right, how many of these single atoms will fit in this 1 kilogram block? So in other words, how many of these 3.95 times 10 to the minus 22 will fit in this 1 kilogram? So all I'm basically doing there is 1 kilogram divided by my 3.95 times 10 to the minus 22 grams. Are you able to do that? Well, no, because look, what I've got there is like 1 kilogram divided by something else in grams. So my units don't match up. It's a bit like saying, what's 1 elephant divided by 6 giraffes? It has kind of no meaning. I need to work in the same language, right? So in other words, what I need to do is I need to convert this kilograms into grams, or I need to convert these grams into kilograms. Now, I know what I'd rather do, okay? It's up to you. But look, this bottom one involves standard form, right? So if I'm going to convert these grams into kilograms, then I'm going to have to fiddle around with this standard form. I don't want to do that. Whereas look, on the numerator, 1 kilograms, I know that 1 kilogram equals 1,000 grams. Equals 1,000 grams. So I can easily just swap that over to be 1,000 grams. Great, now I'm working the same units. I can just get rid of those units at the end so I don't confuse myself. So yeah, units is really important. And this is true for any question, actually, particularly stuff to do with distance, speed and time, right? You might, for example, get given a distance in kilometres and a speed in miles per hour. So what you've got to do there is convert kilometres into miles, so then you're working the same distance. Or you might, for example, get given a speed in miles per hour, and you might get given a time in seconds. So you need to convert time into hours, right? So yeah, just make sure your units basically match up. Okay, so let's try and have a look at this then. Let's try and have a look at this thing here. Let's try and evaluate it, because that's what we're after. So 1,000 divided by 3.95 times 10 to the minus 22. Well, look, we are asked just for an estimate, right? So we're not expected to be able to divide by 3.95. So let's just choose a number that is close to 3.95 that we can easily work with. Well, I think 4. 4 would work pretty well. 4 would work pretty well. So if we convert this into a 4, that would work pretty well, right? So in other words, what we're doing is we're just saying, right, this 3.95 grams, 3.95 times 10 to the 22 grams is roughly 4 times 10 to the 22 grams. So that's all we're saying there, all right? Okay, can we do that then? Well, in my head, no, right? Because what I've got on the bottom is stuff involving standard form and stuff on the top. So I'm trying to do 1,000 divided by 4 times 10 to the... I just can't do it. So it makes sense then to convert the numerator into standard form as well. So what is 1,000 in standard form? 1,000 in standard form. Well, are you happy it's just 1 times 10 to the 3, right? Because 10 to the 3 just simply means 10 times 10 times 10. 10 multiplied by itself 3 times. And I've still got the 1. So it's 1 times 10 times 10 times 10. So what's 10 times 10 times 10? It's just 1,000, right? So I've just got 1 times 1,000, which is just 1,000. So it's just 1 times 10 to the minus 1 times 10 to the 3. All right. So I've now converted it into standard form. Right. Okay. Let's just do a quick thought experiment. Let's say I had 2/5, okay, and I multiply it by 4/9. Right, what do I do when I multiply fractions together? I just multiply the tops together, so I get 2 times 4. And on the denominator, I get 5 times 9, because I just multiply the bottoms together. All right, so are you happy then? I could also work in reverse. So in other words, I could take this, and I could split it up into 2 individual fractions. So that's exactly what I want to do over here. Because I could take this, okay, I've got 1 times 10 to the 3, got 1 times 10 to the 3, so this is just over 4 times 10 to the minus 22. This is just the same as 1 over 4 times 10 to the 3 over 10 to the minus 22. Are you happy that that is exactly the same as that? Because if I work backwards, I just multiply the numerators together to get that, all right? And then I just multiply the denominators together to get that. That looks pretty good to me. All right, okay. So now I've got this. Well, look at this. This looks suspiciously like laws of indices. Okay, what laws of indices do I know? Well, this fraction just really means divide, right? So this really just means 10 to the power of 3 divided by 10 to the power of negative 22, all right? So what is 10 to the power of 3 divided by negative 22? So I just subtract the powers. So 10 to the power of 3, subtract negative 22. Be careful, I've got a double negative going on. So I know that a double negative just simply means a plus, just simply means positive. So what's 3 plus 22? That's just the same as, so it's just the same as 10 to the power of 25. So I can just simply change all of this now, all of this into 10 to the power of 25. Okay. So can I do anything with that? Well, yes, I can, because what do I know about a quarter? Can I write that as a number? Can I write that as a decimal? Yeah, quarter is just 0.25. 0.25. So there's my answer. Except I could do a little bit better, because after going to all this effort with standard form, I could at least leave my final answer in standard form, right? So remember my standard form, it has to be a number between 1 and 10 here, all right? Is that a number between 1 and 10? No, it's not. So in other words, I need to make this into a 2.5 times 10 to the something. Well, what's it going to be? Well, look, in order to turn this 0.25 into a 2.5, are you happy I'm just going to have to multiply by 10? All right? But I've upset the equality of my equation, because if I've multiplied by 10 on this side, all right, I need to also multiply by 10 on this side, which I don't really want to do, right? So if I multiply by 10, how do I get rid of a multiply by 10? I have to divide by 10 here, all right? So in other words, I have to divide by 10 here. So what's 10 to the 25? What's 10 to the 25 divided by 10? Well, this is just really 10 to the 1. So I just subtract the powers, so it just becomes 10 to the 24. So in order to go there, I just become 10 to the 24. So there's my final answer. It is 2.5 times 10 to the 24. All right, now let's just very quickly look at part B. Is your answer to part A an underestimate or an overestimate? Give a reason. Well, look at what we had to do. It's all to do with how we made the estimate, right? Remember what we did? We converted this 3.95 into 4. All right? So in other words, we rounded up, which means that our final answer is going to be a, what's it going to be? Is it going to be an overestimate or an underestimate? It's going to be an underestimate, isn't it? Because even though we rounded up, it's not an overestimate, because look what we had to round up. We rounded up the denominator of the fraction. So if, for example, you know, I had a third, all right, and I changed it into a quarter, what's bigger, a third or a quarter? Well, let's plot it on a number line. So there's a quarter is here, a quarter's here. Where's a third? A third is here, all right? So by rounding up, what I'm actually ending up with, so there's my quarter, there's my third. So what I'm actually ending up with is an answer which is less than the true value. Because I rounded up, you have to think where I rounded up. I rounded up in the denominator, all right? So in other words, I made the denominator bigger. Which means that I made the overall number smaller, all right? Because there's a third, there's a quarter. So I made the overall number smaller. So I rounded up, but I rounded up in the denominator. So I'll end up with an overestimate. Sorry, an underestimate. So I'll end up with an underestimate. Because I'll end up with a number that is smaller than the true value. All right?